Here we actually look at our six trig functions. We're probably familiar with sine, cosine, and tangent. They're reciprocal functions listed right next to each other called cosecant, secant, and cotangent. Very quickly here off to the side, I've already mentioned the idea of our coordinate plane. So here's my x and y axis. Said angle is in standard position when it has its initial side on the positive x-axis. So we're going to start here. There's a terminal side in one of the quadrants. I'm just going to make a terminal side here in quadrant number 1. If I were to come straight down from there, that would create a right angle with the x-axis. And on the x-axis, the distance covered from the origin over to here is going to be x number of units. From here, we're going up on the y-axis, so this is the y-axis, the y number of units. And then eventually a lot of our work is with a circle, so we label the hypotenuse of our triangle as r for the radius of a circle as it goes around here. That we'll touch on that later. But you can see our definitions here are in terms of x, y, and r, not in terms of opposite, adjacent, and hypotenuse like they have been previously. So sine is y over r, cosine is x over r, tangent is y over x. You might remember that sine is opposite over hypotenuse. So here, opposite is y, hypotenuse is r, so y over r. Cosine is adjacent over hypotenuse. Well, the adjacent side here is x, hypotenuse is r, and tangent is opposite over adjacent, or y over x. So again, what we're going to see here moving forward is you need to know your trig definitions in terms of x, y, and r, but also in terms of opposite, adjacent, hypotenuse, and we'll touch on those as we go. Mention these reciprocal functions. Cosecant is reciprocal of sine, so sine is y over r, cosecant is r over y. Cosine is reciprocal of secant, cosine is x over r, so secant is r over x. And tangent is reciprocal as cotangent, cotangent is y over x, so cotangent is x over y. Three new functions you probably haven't seen before. You're familiar with the Pythagorean theorem, but you usually see it as a squared plus b squared equals c squared. We will see it here obviously as x squared plus y squared equals r squared, with x and y being the two sides of our triangle and r being the hypotenuse or the radius of the circle. One important note to make here is as we move around our coordinate plane, x and y can be negative numbers. As over here, for example, we're over negative on the x-axis because we're to the left of the origin. If we were to come down the third quadrant or the fourth quadrant, y would be negative. But make a mental or a physical note to yourself, r is always a positive number. Our hypotenuse is always positive regardless of what quadrant we're in. R is always positive. Again, x and y can be negative depending on what quadrant we're in, but r will always be a positive value. So with that coordinate plane, we can use our coordinate plane and an ordered pair that's on the terminal side to find our six trig functions as long as we know x, y, and r. So looking here at number 1, it says the terminal side of an angle, theta. Again, angles here in trig are typically going to be in what we call Greek letters. This is a Greek letter theta. You might see alpha, you might see beta, you might see gamma. Those are some of the common ones, but typically as you move up in upper level math books, your angles will be listed as Greek letters and your sides will be as regular alphabet letters, A, B, C, D, E, and so forth. But anyway, angle theta is in standard position, passes through the point 815. We're going to find our six trig function values. I won't be very good at it here, but I'm going to try and sketch that point 815. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So right there is the ordered pair on our terminal side. So our terminal side runs through that point. All we're going to do is use that point and come straight down and make our right triangle. So here we have our right angle, which means we've come over 8. We've gone up 15. Now we might remember that triangle from geometry, an 8, 15 something triangle. If we don't, we'll go 8 squared plus 15 squared equals r squared. X squared plus y squared equals r squared. 8 squared is 64. 15 squared is 225 equals r squared. So r squared equals 289. If we take the square root of both sides, r equals plus or minus 17. Positive or negative 17. We just established that r is always positive, so we'll eliminate the negative version of that, so r is 17. So for our purposes, we now know that x is 8, y is 15, and r is 17. Once we know those, it should be pretty easy to come up with our 6 trig functions if we know our definitions, because sine is y over r, or 15 over 17. Cosine is x over r, or 8 over 17. And tangent is y over x, or 15 over 8. Writing down our reciprocals, I always like to write the reciprocals right next to their original functions. So the reciprocal of sine is cosecant. If sine was 15/17, cosecant is 17/15. Reciprocal of cosine is secant. If cosine was 8/17, secant is 17/8. And the reciprocal of tangent is cotangent. Tangent was 15/8, so cotangent is 8/15. So there's our 6 trig functions by using an ordered pair on the terminal side of our angle. Starting all over again, but maybe shortcutting this one a little bit. Terminal side of an angle theta in center position passes through point -3, -4. Find the values of our 6 trig functions of angle theta. Well, I'm not going to draw this one out because right here I have an ordered pair. An ordered pair consists of an x and a y. So right off the bat, I know that x is -3 and y is -4. And I can use my Pythagorean theorem to find my missing side, or maybe I know my triangles. But just to make a point here, -3 squared plus -4 squared equals r squared. Be careful when you type this into your calculator, because we all should know that -3 squared, or -3 times -3, is a +9. If you type that into your calculator incorrectly, you might get -9. Obviously going to throw off your answer. -4 times -4 is 16. Not a -16, but a +16. So 9 plus 16 equals r squared. R squared equals 25. R equals 5. So we have a 3, 4, 5 triangle. And now we can come up with our 6 trig functions. Sine, once again, is y over r, or -4/5. Cosine is x over r, or -3/5. Tangent is y over x, -4 over -3, or a +4/3. Cosecant is reciprocal of sine, so it's -5/4. Secant is reciprocal of cosine, -5/3. And cotangent reciprocal of tangent, which is 3/4. All right, so there's our 6 trig functions. Continuing with a few more to get us through this. Find the 6 trig function values of angle theta in standard position if the terminal side is defined by x plus 2y equals 0 and x is greater than or equal to 0. We don't have an ordered pair this time, but we do have the equation of the line that creates that terminal side. So what I'm going to do is take this line and put it in slope-intercept form by solving for y. So I'm going to subtract x from both sides, which will give me 2y equals -x. Slope-intercept form means I want to solve for y. So y equals -1/2 x. If we were to actually graph this, we would want to make an xy ordered pair chart and plot a few points. In this case, I just need one x and one y to be able to find my r and find my 6 trig functions. So, excuse me, up here it says x is greater than or equal to 0. What that means is x is positive. So I can choose any positive number here I want to. I can do 1, 2, 3, 4, 5, 6, 7, all the way up to 10,000, 20,000, whatever we want to do. But let's make life simple. Because I have a fraction here, I'm going to use the number 2. Because now, in this equation, y equals negative 1/2 times 2. That will give me a whole number for my y because the 2's will cancel and y will equal negative 1. So by finding that ordered pair, I now know that x is 2, y is negative 1, and I can use that to find my r. So 2 squared plus negative 1 squared equals r squared, or 4 plus 1 equals r squared equals 5, or r equals the square root of 5. We'll leave that as an exact answer. I want our answers to be exact. So that will then allow us to go ahead and find our 6 trig functions. Sine is y over r. Bring in what we know from Algebra 2. We can't have a radical in the denominator, so I have to rationalize that by multiplying top and bottom by the square root of 5. So I wind up with negative 1 times the square root of 5 over 5 for my sine. Cosine is 2 over the square root of 5, x over r. Again, can't have a radical in the denominator, so let's multiply by the square root of 5. I have 2 square root of 5 over 5, and tangent is y over x, or negative 1/2. Reciprocal functions. Go back to here and just flip this one over, so I have the square root of 5 over negative 1, or just negative square root of 5. Secant theta, flip this one over back here to our starting point, square root of 5 over 2, and cotangent, flip negative 1/2, gives us negative 2. So there's our 6 trig functions. Couple of special situations here in number 4. 4a says to find it for negative 90 degrees. I am going to go ahead and sketch this one. Negative 90 degrees would be the angle from here to here. So I don't have essentially a terminal side. I have a quadrantal angle. So my terminal side is right here. I don't have an ordered pair. However, we can pick any ordered pair we would like on this line. We could go here, here, all the way down here if we wanted to. But just to work with some easy numbers, knowing this is our origin, 0, 0, we've gone over 0 units, and the easiest number I can think to work with is the number 1. So I've gone over 0 and down 1. So that ordered pair, I know x is 0, y is 1. That will allow me to find r. Well, I'll write it out. 0 squared plus 1 squared equals r squared. 0 plus 1 equals r squared. So r is also going to equal 1. Okay. Once we have that, we can find sine, cosine, and tangent. Sine is y over r. Well, 1 over 1 is 1. Cosine is x over r. 0 over 1 is 0. Tangent is y over x, which is 1 over 0. Can't divide by 0, so tangent is undefined. Cosecant is a reciprocal. 1 divided by 1 is still 1. Secant is reciprocal. 1 over 0, which makes it undefined. Can't divide by 0. And cotangent will now be 0 over 1, or 0. So we're on one of the x or y axis. We're going to work with zeros and ones all the way through there. Letter B will illustrate how they all simplify down to be the same number regardless of what ordered pair we use. We could have used 0 and 10 here, and we would have got these same trig functions over here that we got with using 0 and 1. Okay, so let's take a look at that letter B. Our terminal side passes through 3 and 0, or negative 3 and 0. So right away, again, negative 3, y equals 0. If we do our Pythagorean theorem, negative 3 squared plus 0 squared equals r squared, or 9 plus 0 equals r squared equals 9. So r is also going to equal 3. Sine is x or y over r, 0 over 3, which is 0. Cosine is going to be x over r, negative 3 over 3. Simplifies to be negative 1, like we had up above. Tangent, theta equals, tangent is y over x, 0 over negative 3, or 0. Cosecant is going to be 3 over 0. 3 over 0 is going to be undefined. Secant, 3 over negative 3 is still going to be negative 1. And cotangent is going to be negative 3 over 0, or undefined here as well. Okay, so again, regardless of if we're on a coordinate or a quadrant x, y axis, we need to use any point on there, and we'll simplify down to be the same number, so 0 and 1 is probably the easiest way to go. Oh, we have 4 left to finish that are along those same lines. If you scan through these, all these angles, 90, 270, 180, 360, are all on the x or y axis. So over here, I'm going to use an x and y axis and just put each of those angles in. So 90 would be here. For an ordered pair, we'd have 0 and 1, which means r would be 1. Cosine is x over r. Well, x is 0, r is 1, so we have 0. Plus 3 times something. If I go to 270, my ordered pair will be down here. I use 0 and negative 1. Well, my r will also be 1 there. I'll just write it outside. Sine is y over r, or negative 1 over 1. So I have 0 plus 3 times negative 1, or this simplifies down to be negative 3. Continuing on, letter B, 3 times the secant of 180 minus 5 times the tangent of 360. 180 is right here. So I have 0, oops, let's try that again, negative 1 and 0 gives me an r value then of 1. Secant is r over x, so it's 3 times 1 over negative 1, minus, we'll go to 360. 360 takes us all the way around to here, so I have 1 and 0, gives me an r value of 1. Tangent is y over x, so it's 0 over 1. 3 times negative 1 minus 5 times 0, negative 3 minus 0, or we just have another value here of negative 3. Oh, we have 2 more of these. Looks like I lost my coordinate plane, so I'm going to sketch this back up here again for us to use. You might be able to use the same one. We're at 360, so that's all the way around, 1 and 0. With an r value of 1. 180 is here, negative 1 and 0 with an r value of 1. And 180 again, so I have those numbers on there. Tangent of 360 is 0 over 1, or 0. Sine of 180, sine is y over r, 0 over 1 is 0. And cosine of 180 squared, well, 180, or cosine of 180, cosine is x over r, so negative 1 over 1, that's being squared. These first two are easy. I'll go ahead and write them in anyway. But here our order of operations tells us we do exponents first, so negative 1 squared is 1, so I have 5 times 1, or 5 here as my simplified version. And one last time here, we have letter D, secant squared of 180, 3 minus 3 times the sine squared of 360, and plus the cosine of 180. So secant 180 we already have drawn in. Secant is r over x, so it's 1 over negative 1, squared, minus 3 times something squared. 360 is over here. Sine is y over r, well, that's easy. 0 over 1, or 0, being a square, 0 squared is still 0. And the cosine of 180, cosine is x over r, negative 1 over 1 is negative 1. Negative 1 here squared is a positive 1. 3 times 0 is 0, and plus a negative 1, so this simplifies all the way down to 0. And I believe that gets us through section 3.